lining the Coachella Canal. The Coachella Canal is a branch of the All-American Canal in Southern California that feeds the agricultural industries of the Imperial and Coachella valleys. The problem is water loss from the point of origination through the unlined canal by seepage through the sandy soil of the desert. The purpose of this demonstration project was to seal the existing canal without interruption of water delivery and with little environmental impact. A continuous water supply is required 365 days a year, so dewatering the canals was not a viable alternative. Building a new waterway and abandoning the old is expensive and not preferred. 38 miles of the Coachella Canal were not lined. It was estimated that lining that section could conserve 9.8 billion gallons of water. The section of the canal for the test project was 1.5 miles of the Coachella Canal, just northeast of Milan, California. The canal is roughly 11 feet deep, with a bottom width of 50 feet, and 2.5 to 1 sloping walls. Project funding was from the Coachella and Metropolitan Water Districts and the Bureau of Reclamation. The prime contractor was Kiewit Pacific Company of Santa Fe Springs, California. The manufacturer, Gomaco Corporation of Ida Grove, Iowa. The manufacturing effort resulted in 2 4-track machines with truss framework 26 feet high and 112 feet wide to span the widths of the canal. Each track was 22 feet long and 30 inches wide. Special handling devices were designed to provide in-position welding of the large sections. Both machines were assembled and thoroughly tested in Ida Grove, Iowa. The test project would involve the placing of PVC plastic sheeting with a concrete layer slip-formed over to hold the PVC blanket in place. The leading machine would hold a mudcat trimmer with a small dredge cutter head. The mudcat was carried on the truss work to provide lateral travel and operation. Two steel cables were mounted to the machine for accurate grade. The cutter head was censored to provide trimming to the canal profile. The mudcat was modified for using the Gomaco microcontroller system for cutter head grade control. A suction pump allowed material to be discharged away from the operation. The trimmer framework also contained hoppers and screed arrangement to fill in areas below grade. A Gomaco 8500B was utilized to place 1-inch minus gravel onto the trimming conveyor system. This system would carry the gravel to the top and across the half-width trimmed area. A divertiplow would direct the fill material into hoppers for placement by the screed in the low areas. The trimming and screed operation were completed in a single pass. In addition, trimmer heads were mounted to the framework to trim the berm for the track line and the slope above the water level. Trimming continued into the evening hours to keep ahead of the paving operation. The second machine, the slip-form paver, featured an upper deck to accommodate the PVC. Prior to paving, a geotextile was spot glued to the 30 mil PVC polyvinyl chloride sheeting and rolled up. The geotextile was on the slopes to keep the concrete from sliding. The rolls were about 2,500 pounds each, 60 feet wide and 200 feet long. The PVC was draped from the upper deck down the front of the machine and guided under the paving mold. The Coachella paving form was modified to provide computer-controlled pressure-compensated surge plates to sense any changes in subgrade conditions. A prototype system was manufactured and tested in Ida Grove, Iowa. The paver was equipped with water curtains or hydraulic gates to divert the water. Two methods were used to get the concrete to the hopper. Originally, it was set up similar to the screed operation, central mix to end dump trucks. The concrete was discharged into a Gomaco 8500B that placed the concrete onto a conveyor system, and a diverter plow system loaded the concrete hopper. After modifications to the paver, transit mix trucks discharged directly into an extended conveyor on the paver. A concrete pump was then used to feed the mold, and a conveyor was added to the opposite side of the paver to accept concrete from the trucks and discharge directly into the hopper on the slope side of the mold. This provided continuous paving and up to 2,200 feet of production in one day. The paving mold was equipped with hydraulic gates to hold the concrete supply and allow the mold to be raised above water level to be charged and then lowered into position and opened to commence the paving operation. The gates would close to terminate the operation and to allow the mold to be raised for cleanup. A reversible auger ran the length of the mold, and 36 vibrators were positioned every 18 inches. A specially designed concrete mix included an anti-wash additive that gave the concrete a gel-like consistency to resist washout. The initial attempt to slip-form the mix design was in Ida Grove, Iowa, with an experimental mold. The test was a check of the slip-form capabilities of the mix design, the ability to pave over the PVC, and the ability of the design to repel water. Animal escapes were designed into the slope profile, and longitudinal control joints were built into the paving mold. Originally, a curing membrane was placed on the concrete above the water level. In the latter pour, cure was sprayed on the exposed portion to prevent surface cracking. After completion of the project, a section of the canal was drained. The visual inspection revealed matching slabs and a smooth, consistent lining. Research will continue on the merits and effects of this demonstration project. The lining of a canal with uninterrupted water delivery. Gomaco, a worldwide leader in canal paving technology.